Okay, everyone. So I will start the class. I hope I am audible. So
Yes, sir.
yeah. So I am taking the problem solving session for this NPTEL online course, that is Wastewater Treatment and Recycling. So we are into week 2 now, and I am Akash Saha, and I am a Prime Minister's Research Fellow pursuing my PhD in the field of environmental engineering at IIT Madras. So last week was a kind of introductory session. So this is the brief overview of week 2 lectures. So we have seen uh, topics regarding wastewater generation and quantity estimation, where we studied like what is the need of quantity estimation, what is the concept of dry weather flow, and different types of sewage, separate and combined systems. Then we moved on to the quantity estimation of sewage, where we have seen the input components of the sewage, the steps for estimation of the sewage flow, and how to calculate the design period of the sewage networks, and then the estimation of the design population. And then we moved on to the population forecasting methods, where we learned about various methods like the arithmetic increase method, the geometric increase, incremental increase, and etc. And at last, we learned about how to calculate the peak flow estimation, the additional losses, and etc. Then we've solved some of the properties problems. So right now, to help you solve your assignment problems, I have a few more question answers. So we will go through each of the questions and try to learn few more things. So this is the first question, which says estimation of agricultural runoff depends on A, type of crop and cropping pattern, B, irrigation supplies, C, precipitation, D, all of the above. So what would be the correct answer? Can someone type it in the chat box? So here we are talking about the estimation of agricultural runoff. Can someone tell me whether agricultural runoff is a point source or a non-point source? We have learned this.
9 point source.
Yeah, it's most generally a non-point source. So, like to estimate this kind of agricultural runoff, what are the factors it would depend on? So we have four options here. So can someone tell me in the chat box what is the right answer? These are very easy questions. We can go
It
through.
is D, all of the above.
D, all of the above. Okay. Aditya is saying it's precipitation only. Anything else? Anybody else wants to share their views? Okay. So the correct answer is all of the above, because see, the type of crop or the type of irrigation we are providing, it will actually read on to how much runoff will be coming off from the system. So also precipitation is another factor. So here the correct answer will be all of the above, not just option A or B or C. It's all of the above. Everything will depend on the runoff. Okay, so this is the next question. This is a small numerical question where we have to find the population density. So the question says, if the development plan rules of a city provide the following reservations for different land uses, suppose roads they have given for 15%, garden 10%, school 5%, markets 5%. So we have to calculate the population density per hectare for the plan, and we should assume an FSI of zero point 0.5 and the floor area as 10 meters square per person. So it's a very short numerical. I think it is similar to one of the examples we have seen in the lecture. So can someone tell me like what would be the first step? What we have to find out first? If we have all this data, what would be our first approach? We have to find the population density, right? So what will be the first parameter we have to look for? Here we are talking about the percentage of roads, gardens, schools, and markets. Yes, Javed, we have to see like how much area is available for residential part. Okay, so if other things are given, so we can find out the leftover part as the residential part. So can someone tell me what will be the percentage of the residential area? 65. Yes. Yes, you are right. So if 65% is a residential area and the FSI is zero point 0.5 and the floor area is 10 meters square per person, so what would be my population density per hectare? Here I am talking about per hectare. Okay, we will see the answer. Java is saying it's 325. Yes, it is 325. So we'll see the solution one by one. So at first stage, we will find out the area available for the residential development. So it would be total 100% minus all the different contributions from road, garden, schools, and markets. So we get 65%. Then we will find the actual total floor area. So it would be the total residential development area into FSI, which is given as zero point 0.5. Then the population density per hectare would be 0.65 into zero point 0.5, which is the FSI, into 10,000. What is this 10,000? Can anybody tell me? The class should be a little interactive, otherwise there is no point of having a problem solving session. Okay, yes, Javed, you are right. So this is to convert hectare into square meters because we have been given the floor area as 10 meter square per person. Okay, so it's just a conversion factor. So now, so like that we get 325. If anyone else have any issue with this question, they can ask me right now. You don't have to wait till the end. You can ask me right now. Is it fine? Can anybody else apart from Javed gives a thumbs up that they have understood the problem? Because I am seeing only Javed is answering. Okay. Anybody else? I hope I am audible and the voice is clear so that you can understand the problem. Okay. Okay, we'll move on to the next question. So the next question is, which of the following parameters is not used to quantify the municipal wastewater generated from a city or town? Here we are talking about the parameter which is not used. So the first parameter is total population, then per capita water demand. Third is the percentage of utilized water reaching the sewers, and the last option is storm water received in the city. So which of the following factor is not used for municipal wastewater generation? Aditya is saying it's D. Anybody else wants to try? Tejas is saying it's C. Okay. Sakit is also saying it's D. Okay, so we will see what is the correct answer. So the correct answer is stormwater received in the city. See, stormwater is not a part of the municipal wastewater. Okay, it though it sometimes infiltrates into the sewers, but we don't design it for stormwater if unless and until it's a combined system. Okay, so when we are talking about municipal wastewater generated, we won't consider the stormwater. And Tejas has and if we talk about the like percentage of utilized water, so the water that we are utilizing in our daily use, in like in bathrooms or kitchens, it will convert into wastewater, right? So it will be a crucial factor in the municipal wastewater generated. So C is not the correct answer. D is the right answer. Okay. So we'll move on to the next question. Okay. The population of a plant city needs to be forecasted for a period of 50 years. Which of the following methods will generally result in the highest design population? So this is a question from population estimation. So what do you think? Like which method will give the maximum population?
This
Okay.
is a B. Geometric increase method is getting the maximum population.
Okay.
Geometric.
Okay. Anybody else? Okay, everyone is saying it's B. Okay, yeah, B is the right answer, geometric increase, because arithmetic increase will give the least increase. Okay, and incremental will be in between arithmetic and geometric. And D option is wrong because all the methods are different, so there is no point that it would all be the same. Okay, so the next question. Again, a numerical, a very small numerical. The total population recorded in 2001, 11, 21 for a city was 4.2, 5.6, and 7.2 lakhs respectively. So we have to use arithmetic increase method to find the population in the year 2051. Very simple problem. You can do it in like few seconds. B. Okay, Saket is saying it's B. Anyone else? It's a pretty simple problem. Okay, Javed is also saying B. Okay, so I will see the solution. B is the correct answer, 11.7 lakhs. So first we will find what is the population increase per decade. Okay, so here for the first decade it's 5.6 minus 4.2, that is 1.4 lakhs, and for the next decade it will be again 1.6 lakhs. So the average increase in the population would be around 1.5 lakhs per decade. So if you want to calculate the population in 2051, that is after 3 decades from 2021, so it would be like what is the population in 2021 plus 3 into the average population increase. So it's pretty simple. It would be 11.7 lakhs. I hope it's clear. It's a very easy problem. You might have already practiced. If you have any doubt regarding any of the question, you can ask me. You can unmute yourself and ask me. Okay. So we will move on to the next question. The master plan method, we are talking about the master plan method of population estimation, is based on population density and zone size, annual birth or death rate and migration rates, growth rate characteristics, and or the ratio of local to national population. So on which of the following factor the master plan method depends on? A. Okay, Javed is saying it's A. Everyone is saying it's A. Okay, can someone tell me, like, for the option D, what is that method called as? For option D, what is the method called as? Very simple. For option D, what is the method called as? Yeah, it's the ratio method. And what about the option B, annual birth and death rate and migration rates? Option B, which method do we consider the birth, death, and the migration rates? Can anyone tell? Have you heard about growth composition method or demographic method? Yes, demographic method. Okay, so correct answer is A for the master plan method. It depends on the population density and the zone size. Okay, so the next question. For the design of sewers, estimates of per capita sewage generation is usually based on. Okay, for the design of sewers, on what factor the per capita sewage generation is based on? Is it on population? Is it on design period, recommended water use and wastewater generation pattern, or the wear and tear of sewers? So we have to think about on which factor our per capita sewage generation will depend on.
It's C.
It's C. Can you can anyone else try? Javed is also saying C.
It is
Tejas,
D. It is D. Wear and tear of the sewers.
okay. So I got every answer. Someone is saying it's A, someone is saying it's B, C, and D. Okay, so we will go one by one. Okay, so first is design population. Suppose at a place we have a population as 50,000 and at a place we have a population of 1 lakh or maybe 10 lakhs. How would the per capita sewage generation will depend on it? On population, it would never depend, right? Because it's per capita. We are talking about per single person. Then design period. Also, design period doesn't play a role on the per capita sewage generation. So only the water use pattern, like how we are using the water we are getting from the municipality, like how frequently you are using, how much you are using, okay, and what different water use patterns we are using. So the estimate of per capita sewage generation will be dependent on only C. And the option D, wear and tear of sewers, these are all leakages. We cannot, like, we have to consider it externally, but per capita will not depend on the wear and tear of sewers. Am I clear? Because I got mixed result for this question. Okay, okay. I hope I am clear. Okay, so the next question. Arrange the steps of quantity estimation of sewage in correct order. So we have different steps of quantity estimation of sewage. We have estimation of peak flow, we have estimation of the design population, the design period, and the accounting of the additional inflows. So Javed is saying it's B. Okay. Naveen is also saying it's B. Everyone is saying it's B. Just think about it. In B, first, just think about it. We have to first estimate the design population or the design period. What is the basic requirement of designing the population? We need to know, right? Like at what what till what year we have to use the system. So fixing the design period is necessary in the first place. Okay, so we'll see the answer. C is the correct answer because at first we will fix the design period, and based on that, we will then move on to designing the population. Then we will estimate the peak flow, and at last we will account for additional inflows. There are two, three steps more, but I have not included it here. It's just to make the question. So C is the correct answer. Okay. So the next question. Under which of the following population forecasting method, the maximum population of the city is limited by saturation population or the carrying capacity? Is it graphical, demographic, ratio, or logistic growth? Okay, Tejas is saying it's D. Okay, it's a pretty simple question. So the answer is logistic growth method. Can someone tell me what is the curve of the logistic growth method is called as? By what other name?
S-shaped curve.
S curve. Okay, yeah, it is the right. So we can see by the yeah, yeah, it is right. So uh, so based on the saturation population, we try to forecast the population in this method. Okay. So the next question is population growth is progressively increasing or decreasing is an assumption under which of the following method for population forecasting. So in one of the population forecasting method, we are considering that population growth is increasing or decreasing.
A incremental increasing method.
Yeah, yeah. Can someone tell me why incremental increase method? Why not arithmetic method?
Because it is progressive.
Yeah, okay. We are also finding the incremental change. After finding the change in population per decade, we are also finding the incremental change. Okay, so it can either increase or decrease. So the correct answer would be incremental increase method. Now, What is the recommended design period for pumping mains by CPHEEO? Design period for pumping mains.
That is 15 years, 15 years.
15 years. Okay. Amit is saying is 30 years. Okay. So the correct answer is B, 15 years. Here we can see all the design periods for different components of the sewage system or the water supply system. So pumping means it is 15 years. Now the next question. Among the following commercial institutions, the expected generation of wastewater is highest from? Is it schools, hospitals, restaurants, or cinema halls?
Hospitals.
Yeah. So everyone is,
Hospital
C.
with beds.
yeah, it is very easy. So correct
Restaurant.
answer. No, it is actually hospital with beds. So here we can see, like, for hospital with laundry and beds, we have 340 to 450 per bed, whereas it is much lesser in the case of schools, like 45, restaurants 70, or cinema halls it's around 15. So for hospital it's the highest. Okay, the next question. Determine the approximate quantity of wastewater generated from the city where the per capita consumption is 165 LPCD and the conversion factor is 85% to wastewater, and the population of the city is 1,65,000. So we have to find out the approximate quantity of wastewater generated.
27
5,
mld.
27 MLD. Okay. Anyone else?
23.
23. So two different answers.
23. C is
Okay, so
23.
we will see the answer. So it's
23.
23 MLD. So we will see the solution. Population is 1,65,000. Per capita water demand is 165. So the total water used will be 165 into 1,65,000. Okay. Then the total wastewater generated will be 0.85 into the total water used, which will be around 23 million liters per day approximately. So the next question, the inflow in sewers may exceed the design flow due to sprinkling over the roads, household using private water supplies, water used in horticulture and landscaping, none of the above.
Householders using private water supplies.
Okay. Okay, so everyone is unanimously saying B. So it is the correct answer. So what would happen because of sprinkling of water over roads and water used in horticulture? How it would affect? How would it affect my design flow?
We don't know how much sewage is. We can't imagine how much is coming.
Yeah, by using household private water supplies, we are exceeding. Okay, we are exceeding the design flow. But if you are reusing it, then how would it affect our flow? Will it increase or decrease our flow?
Increase.
No, I'm asking about sprinkling over roads or water used in horticulture. Increase will
This
be because
will decrease.
it will decrease. It will decrease
Yes,
my flow.
because there's loss of water
Yeah, it is the loss
not
of water.
entering.
Yes, exactly. So B is the correct answer for this question. But what I was asking about the decrease in flow. Okay. The next question. The dry weather flow of a community is usually less than the per capita consumption due to evaporation loss, ground seepage, sewer leakage, any of the above. Any or all the above. Yeah. So it's a
Or
pretty safe.
Sewer leakage.
No, so the correct answer will be D, like all of the above, any or all of the above, because every one of the uh, factor will decrease the flow. Okay, so these are all losses of water. So the correct answer is D. The next question, identify the correct statement concerning the flow estimation in sewer design. So the first statement is the peak factor of a community typically decreases with increase in population. This is the first question. First statement. Then the minimum design flow in sewer may vary from 1 by 3 to 1 by 2 of average flow. Third is the maximum hourly flow is equal to one third of the annual average daily flow, both A and B.
B is the right answer.
You are saying that B is the
Both,
correct option.
Both
Okay.
A and B.
D, both A and B.
both A and B.
Okay. Yes, you're right. The correct answer is D, both A and B. Can someone tell me how to correct the statement C? Like, what is wrong with the statement C?
About peak factor, the peak factor chart is given when the population is increases, the peak factor is decreases.
No, no. I am A. A is right. A and B both are right. That is okay. I am asking, like, the third statement is incorrect. So how would we correct this third statement? Like the maximum hourly flow is equal to how much of the annual average daily flow?
Three times of the average
Three
flow.
Three
times.
times.
Exactly. 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 So for this question, D is the correct option. And can someone tell me what is the equation that we generally use to find the peak factor? Does anyone know about it? There is a CPHEO recommendation for peak factor, but there is one more equation which we can use to calculate. Yeah, this is the ratio, but one more equation to find out the peak factor. Does anyone know about it? It's just an extra information which I will be giving. So there is something called as Goodrich equation. Okay, Goodrich equation, that is 180 times t to the power minus 0.1. So with the help of Goodrich equation also we can find the peak factor, but the time has to be greater or equal to 1. Okay, so this was about the peak factor. So the next question, which of the following factor may cause an increase in population? Here we are talking which are the following factor may cause an increase in population: birth rate, death rate, migration, annexation.
D,
A.
B, 1 and 4.
D.
D, okay, D. Is it B or D?
D for dog. Birth rate, migration,
Okay,
annexation.
okay. Anyone else? Amit is saying it's B. So the question is, which of the following factor may cause an increase? So migration can also cause an increase, right? So I have framed the question is like may cause an increase. So D is the correct answer. Both 1, 3, and 4. Whereas the death rate will cause a decrease in the population. Next question. It's again a numerical on geometric increase method. So the question says for an initial population of 8 lakhs and an annual growth rate of 1.7%, the estimated population after 10 years would be. It's a direct question. If you have the calculator, you can easily solve it in one step. Just please mind, we have to find in terms of thousands. In the question, it is given as in lakhs. You have to find in terms of thousands.
Is 9,25,000, sir?
You're saying B, but many people are saying C. Okay, we'll see the correct answer. I'm just waiting for a few more answers. Okay, we'll see the answer. So the correct answer is C, 814. Yes, Shashi, you have any doubt? I think you raised your hand. Okay. So we'll see the answer, like the detailed solution. So this is a pretty straightforward equation. Initial population into 1 plus the rate growth to the power of the number of tickets. So if we put on all the values, we'll get 814,000. Okay. So typically the peak factor of a community does not depend on which of the factor the peak factor will not depend. Site topography. Okay, let's see.
Dry weather flow.
Dry
A.
weather.
Dry weather flow.
Okay, so many people are saying C, someone else is saying A. We'll see the correct answer. The correct answer would be dry weather flow.
Yeah.
Yeah. So why do you think that C is not a correct option? Like how site topography will influence my peak factor? Can someone tell me?
Water table,
Sorry?
underground water
No, here
under
we
the
are
earth.
talking about peak factor, right? What is
Yes,
peak factor? Peak factor is the maximum demand by the average demand.
yes, and so if an area has an underground water which is near to the sewage, the leakage can cause the peak.
Yeah,
So the
it
topography of the area.
can be one of the answer, but yes, okay. So hot climate, yeah, based on the climatic conditions and everything, it may vary. So peak factor will depend on the site topography also. Okay, so the next last question would be, if the average daily consumption of town is 1,20,000 meter cube, what would be the peak hourly demand? Here we are talking about peak hourly demand. The peak factor is also given 2.7. The average daily consumption is given. You have to find the peak hourly demand. So, yes, Abdul, you have any doubt? You can unmute and speak.
13,500.
13,500. Okay. Anyone else? So, what would be my first step? Saket, can you tell what would be the first step? Like, how did you solve?
So firstly, we divide the population size by 24.
Not the population, the consumption, the average daily consumption. Okay.
Sorry, consumption.
Ha.
We divide
So,
consumption by 24.
to get the average, average hourly
Hourly.
demand. Hourly
Hourly.
demand. Okay.
Then multiply with P factor.
Yeah. So it would be pretty simple. It would be 13,500. Okay. Is it clear for everyone? So these were all the questions that I had that I so we discussed 20 questions. I hope it will help you to solve your assignments. I think tomorrow is the last date. So uh, if you have any more doubt or any other queries, you can ask me right now regarding this week 2 topics. Okay, first question. Okay, I will show you. Just wait for some time. If anyone else, those who have joined late, just want to tell that we have discussed around 20 questions, which would help you solve your assignments. So if you have any queries or doubts regarding any of the modules, you can ask me right now on any topic. We can question number 14. Okay, 1 and 14 we will discuss. Okay, so let me just go back to question 14. Yes, so this was the question. Inflow in sewers may exceed the design flow due to. Oh, you want to know the equation for the peak factor. 14th. Okay, we will discuss it one by one. So first, 14th question. So here we are talking like which of the factor will exceed the design flow. Okay, suppose we have a design flow of 20 meter cube per hour, maybe. So if we are if we are supplying water through private agencies, like which we have not considered in our uh, municipal demand, so it will definitely exceed from our design flow, right? So in this case, B would be the right answer. Whereas sprinkling over the roads or water used in horticulture, these are all, if sprinkling will be a reuse condition, again water used for horticulture will be again a reuse condition, so it will not be contributing to my sewer flow. So in this case, this would all decrease my flow, and whereas the households using private water supplies will increase my flow. Okay, next is question number 19. Okay, so here we were talking like which of the factors that would increase in the population. So birth rate, it's pretty simple. We know that it would definitely increase our population. Annexation. So annexation depends that whenever particular area is like governed by some other people or some other agencies, so it will bring in new people in that area. So it will increase the population. Then migration. Migration can either increase or decrease. We can either move from the city or we can move into the city. So it can cause an increase. Okay. So here we are talking about which may cause an increase to the population. So so all the three options would be correct. I hope it's clear, Prashant.
Yes.
Okay. And the equation which I stated regarding peak factor was Goodrich equation. I will type in the name. Goodrich equation. Okay. So this is another equation, but here in this can be only be applicable if the time is more than 1 day. So for hourly demand, we cannot use Goodrich equation. We have to be based on our observation. And also the first question, right? Or someone wants to see the first question. Okay. So this is the question. Like estimation of agricultural runoff depends on type of crop and cropping pattern, irrigation supplies, precipitation, all of those. So yes, the agricultural runoff will depend on the type of crop, because how much some crops need more water, some crops need less water, so it will depend. Also the how we are irrigating the area, and also precipitation, how much precipitation is happening, rainfall is happening. So all the three factors will contribute to my agricultural runoff. Am I clear? Okay. Anybody else wants to ask any question, or they have any query regarding their lectures or anything? I think more people are joining now. They are joining very late. New candidates, do you want to see the questions again? Just we will quickly see all the questions. Those who have joined just now, we have finished discussing all the questions. So if you want to run through the questions again, I will do that. but I need a feedback.
Yes, sir.
Okay, so I will just quickly run through all the questions. Maybe you can take a screenshot or whatever. Okay, so others, if they don't have any doubt or queries, they can leave the session because I'm just going to repeat all the questions. And those who have joined new, they can just see all the questions, right?
Okay, sir. Thank you.
Okay. So we'll be meeting again next week from 7 to 9 p.m. That is on 15th of August. So we will be discussing the questions related to week 3 module. So please join. Yes, Javed, it is right. This is the equation of Goodrich. But that minus zero point 0.1 should be in power, right? It should be t to the power minus zero point 0.1. So you can make a note of it. It is not t minus zero point 0.1, it is t to the power minus 1. Okay, so I will go through the questions again. The first question is estimation of agricultural runoff. So it depends on either type of crop, irrigation supplies, precipitation, or all of the above. So the answer would be all of the above because the estimation of irrigation runoff will depend on all the three options A, B, and C. Okay, so the next question, it's a numerical where we have to find the population density per hectare. We have been given the different uh, reservations for land uses, that is roads, gardens, schools, and markets. We have been given the FSI and the floor area. So can someone solve it quickly and tell me the right answer? Those who have joined late. It's a pretty straightforward question. We have discussed already. Who have joined new, try to solve this question and tell the answer. Is anyone trying? Okay, Prashant is saying it's A. Okay, so we'll see the solution. So the correct answer is not A, it's C. So first we will find what is the area available for residential development. Okay, so the other reservations have been given. Other reservations are given. So we have to subtract it from 100 and we will get the total residential percentage in percentage. And then we will calculate the total actual floor area, that is the area into FSI, and the population density would be 0.65, that is the percentage of residential area, into zero point 0.5, that is the FSI. Then 10,000 is the conversion factor from hectares to meter square, because the floor area it is given it as per 10 meter square per person. So divide by 10. So it would lead up to 325. So this is the correct answer. Next question. Which of the following parameter is not used to quantify the municipal wastewater generated from city or town? Is not used. So it's a total population, per capita water demand, percentage of utilized water, or storm water district density.
Stormwater received in the city.
Why do you think so?
That one we can't calculate. Such stormwater, how much is coming.
No, it's not about calculation because we can definitely, by some techniques, we can also calculate the stormwater received in the city.
But there is
But
not a waste. There is not a
yeah,
municipal
yeah,
wastewater. No?
it's not a municipal wastewater generator. So D is the correct answer. Okay. Now next question. Uh, a population has to be forecasted for a period of 50 years. So which of the following method will result in a highest design population? So we have arithmetic, geometric, incremental increase method. So which of the following will result in the highest design population? Can somebody tell the answer? Those who have joined late, please try to solve this question. Okay, B. Yes, so B is the right answer because arithmetic will give the lowest increase and incremental will be in between the geometric and the arithmetic method. So B is the correct answer. Okay, Again, a numerical, we have to use arithmetic increase method. The population given for 2001, 11 and 21 are 4.2 lakhs, 5.6 lakhs and 7.2 lakhs. So we have to find the population for 2051. It's a direct question. You can easily solve. Please solve and tell me the correct answer.
12.2.
12.2. Okay. Anyone else? Anyone else who would like to try this question? Vijay, just recalculate it again.
Okay.
You see the solution. It's 11.7 lakhs. So first, for the first decade, the increase is 1.4 lakhs, that is 5.6 minus 4.2. Then for the next decade, it's 1.6 lakhs. So the average increase would be 1.5 lakhs. Okay. So for 2051, it is 3 decades from 2021. So it would be the population in 2021 plus 3 into 3 into the average population increase. So it would be 11.7. Vijay, could you make out what you did mistake?
Yes, sir. Yes.
Okay, it might be a calculation error. Okay, anyway. So the next question. The master plan method of population estimation is based on population density and zone size, annual birth, death rate and migration rate, growth rate characteristics, ratio of local to national population. So master plan method, on which of the factor it would depend? Anybody wants to try? Here we are talking about master plan method. We have different methods for population estimation or forecasting. No one knows the right answer. B. Okay. Anyone else? Prashant, you are saying something?
Yes, yes, sir. Thinking actually, all the questions are looking confusion. So, thing
We
is
are,
related to answer.
we are talking about master plan method. Okay. So just go through one by one. Like try to recall what was master plan method at the first place. So it is pretty, if we have gone through the methods, you will know that master plan method it's based on different zones. Okay, for any city or any area we divide it into different zones and then we will try to calculate the population. So if
It's A.
so it would be A. So it will be on population density and the zone size. Can anyone tell me, like, if I'm talking about annual birth death rate and migration rate, then which method I am talking about? We have different methods, right? In which method we consider the annual birth or death rate or migration rate? Please be interactive. Try to guess something at least. We have seen so many methods. Has anyone heard about demographic method? Hello, is
No,
anyone?
sir. No, sir.
No. If you go through the lectures, there is one method called as the demographic method. Okay, so there we will consider all this annual birth rate, death rate, and migration rate. And based on these parameters, we will try to forecast the population. Demographic. And the last one, like the ratio of the local to the national population, it is called as simply ratio method. Okay, so this was about all these different. So the next question is, for design of sewers, estimates of per capita sewage generation is usually based on design population, design period, recommended water use, and wastewater generation pattern, and wear and tear of sewers. So on which of the parameter the estimate of per capita sewage generation depends on?
See, recommended water use and wastewater generation pattern.
Okay, anyone else?
It's A, sir. Design population.
Design population. Why do you think so? How the population will affect my per capita sewage generation? We are talking about per capita, like per person, how much sewage will be generated per day. So whether the population is 50,000 or whether the population is 50 crores, per person sewage generation will be same, right?
Okay, sir. Okay, yes.
Okay, so correct answer is C, recommended water use and wastewater generation pattern, because based on how we are using the water, okay, either we are using it in drinking, bathing, flushing, what is the pattern when we are using, how much we are using, it will depend, it will affect my per capita sewage generation. So C is the correct option. Okay. So the next, here we are talking about different steps of quantity estimation of sewage. So we have 4 steps here: the estimation of peak flow, population design, fixing the design period, and accounting for additional inflows. So we have to arrange in it correct order. Can someone tell what would be the right answer? Just try to recall how we were estimating the sewage flow, what were the different steps, and then we can arrange it correctly.
I think A, sir. Estimate peak flow.
Estimate peak flow. So you will directly start with estimating the peak flow.
So before designing how much flow is coming, we need to know.
Yes, that okay. We need to know the peak flow, but before calculating the peak flow, we have to find out other things also, right?
It's B, sir. We estimate the design population.
Okay, so you're
Then
talking about design population. So for designing the population, what is the main criteria we should know? Like till how far we have to design the population. So time period is required, right? We should know like what is the time period for which we have to design the flow. So the first would be fixing the design period. So first we have to fix the design period. Then we will estimate the design population based on our design period. Okay, if we don't know till what year or till what century we are going to design the system, we won't be able to design the population, right? And then we will move on to estimation of the peak flow based on our population, because we know based on our contributory population we can find the peak flow, and then we will account for the additional rate. Is it clear, Prashant, Vijay?
yeah, yeah, it's clear, sir.
Yes,
Oh,
yes.
okay. So correct answer would be C. Okay. Under which of the following population forecasting method the maximum population of the city is limited by saturation population? So in which of the method we talk about saturation population? In this method, we believe that the population gets saturated and no more increase would be there. So which of the method considers this assumption? Is it graphical method, demographic method, ratio method, logistic method?
logistic growth method.
Yeah, yeah, it is right. So in logistic growth method, we limit the population to the saturation population, as we consider that as the population reaches the saturation levels, the growth rate nearly becomes zero. So we remember this, there is a S curve. So at the end of the S curve, there is a constant. So the growth rate becomes zero. Okay. Next question. Population growth is progressively increasing or decreasing. It's an assumption for which of the following method? In which of the method we consider that population growth might increase, is progressively increasing or decreasing?
Incremental increase method.
Incremental increase method. It's a pretty direct question. I hope others are fine with this question. So it is incremental increase method. What is the recommended design period for pumping mains by CPHEO manual? So here the design period we are talking about in terms of years. Okay, so it is 10 years, 15 years, 25 years, 30 years. So for pumping
Don't
mains,
mind. So if you don't mind, what is CPHE actually not
CPHU,
in the class?
CPHU you might have studied, right? Because CPHU is the, it provides the guidelines for the design of all these sewer networks, wastewater flow, everything. So you can look into Google and you can find out the CPHU manual. It will
Okay.
provide you all the guidelines or the recommendations for the design of this sewer network. Okay, you should go through it because it's a pretty handy and useful document where you will get all the details and it will help you to design any kind of sewer system. Okay, so I have the clipping of the CPHU. So here they have listed all the components of a sewer network. So you can see that pumping mains, it is designed for a design period of 15 years, whereas civil works of pumping station up to 30 years, sewage treatment plants for 15 years. So we have different design periods. Okay. The next question. Among the following commercial institutions, the expected generation of wastewater is highest. So from these institutions, from where we can expect the highest generation of wastewater per person. We are talking about per person, not cumulatively. We are talking about per person. Is it schools or college, hospitals, restaurants, or cinemas? So you will know this if you have gone through the CPHU manual, because CPHU manual recommends like how much per capita sewage generation should be taken for all these institutions. So if you see the,
One sir, hospitals and hospitals with beds.
yeah, hospital with beds. So if you see all the per capita demand, so for hospital and beds it is around 340 to 450, whereas others are pretty less, like 45, 70 like that. Okay. Now the
Okay,
next
thank you,
question.
sir. Up to here I completed.
Okay,
So
you
thank you
can
so much,
leave.
sir.
You
Okay,
can leave.
okay, thank you, sir.
Anybody else wants me to continue till the last question, or everyone else has seen? So should I go on with the discussion? I need some response.
Yes, sir. Go on.
Okay.
Total, how much questions?
20 questions are there.
Okay.
Anybody
Thanks.
else? Anybody else? Is anybody else listening to the discussion? Or only Vijay is there?
Yes, sir.
Okay. Okay. Fine. Fine. So this is a numerical. We have to find the approximate quantity of the wastewater generated. The per capita demand is given as 165 liters per capita per day. The conversion rate of water to wastewater is around 85%, and the total population is 1,65,000. So what would be the quantity of wastewater generated? It's a pretty direct question, one liner. Maybe you can try it out. So what would be the approximate quantity? You have all the details you want.
C,
C. Okay.
23
Okay.
mld.
Okay. We'll see the solution. C is the correct answer, 23 mld. So the solution is like first the population is given, per capita demand is also given. So total water used will be per capita demand into the population of the city. So it should be around like 27225,000 liters per day. If we change into million liters, we will divide it by 10 to the power 6. And so the total wastewater generated will be 85% because the conversion rate is 85%. So we will get around 23 mld approximately. Okay. Okay. So the next question is the inflow in sewers may exceed the design flow due to sprinkling over roads, household using private water supplies, water in horticulture and landscaping, none of the above. Hello, Kanaya, are you trying to say something? Okay, someone is saying answer is B. Anyone else? Which of the factor will increase the design flow, exceed the design flow?
B. Household using
B.
private water
So
supplies.
yes, so if you are using some private water supplies, it would definitely exceed the design flow. Whereas the other two options, that is sprinkling over the roads or water used in horticulture, it would be it will lessen the flow. Okay, it will decrease the flow. So B is the correct answer. And the next question is the dry weather flow of a community is usually less than the per capita consumption due to, here we are talking about what parameters will lessen the flow. So evaporation loss, ground seepage, sewer leakage, any or all the above.
All.
All the above. So it's a pretty direct question. So it is all because everything will be a loss to the system. Okay, question number 16 now. Identify the correct statement, okay, regarding the flow estimation in sewer design. So the first statement says the peak factor of a community typically decreases with increase in population. Okay. Next one is the minimum design flow in sewer may vary from 1/3 to half of average flow. And the third statement is the maximum hourly flow is equal to 1/3 of the annual average daily flow. And D option is both A and B. So which of the statements are correct here? Please go through the question again. You have to tell me which of the statements are correct. Just go by one statement. Anybody wants to try? Give an attempt. Okay, tell me, is the first statement correct? The peak factor decreases with increase in population. Is it correct? What will happen to the peak factor is the population is increasing. You can directly see it from a table also. Like if the population is increasing, the peak factor
Increasing flow.
it will be decreasing. Okay, it will be decreasing. And also the minimum design flow of a sewer is around 1/3 to half of the average flow. Okay, so minimum design flow will be 1/3 of the average flow. What about the third statement? Is it correct or not correct? Incorrect.
I think so. C is the right answer.
Sorry?
C is the right answer. Third statement.
No, so you're telling that C is correct. That
Yeah.
maximum hourly flow is equal to 1/3 of annual average flow.
No, sir. It cannot be of third.
No, it is not the right. So maximum amount of flow is equal to 3 times of annual average flow. By if you go by thumb rule, it is 3 times the annual average flow.
Okay.
Okay. So C is not the correct answer. Both A and B are correct. I hope it's clear. Okay. So the next question is, which of the following factor may cause an increase in population? So we are talking about increase in population. Is it birth rate, death rate, migration, annexation? We have 4 parameters here. So which of the following will increase the population? May increase the population. Just go parameter by parameter. Anybody wants to give an attempt?
It's C1. C. Birth rate and
Birth rate and
migration.
migration. Okay, yes, birth rate and migration is correct. But what about annexation? Annexation will also cause an increase to the population, right? Because some
Right.
other
Right.
agency or government or some people are coming into the city, so it will also increase the population. So annexation is also right. So the correct answer is D, 1, 3 and 4. Here there is a typo error. It would be D, 1, 3 and 4. Okay, only death rate will decrease the population. Okay, again a numerical, a very simple numerical. You have to use the geometric increase method. The initial population is 8 lakhs. The annual growth rate is 1.7%, and we have to find the population after 10 years. So it's a direct question, one step question. You have to tell me what will be the population after 10 years in thousands. Okay, the population is given in lakhs. You have to tell me the answer in thousands.
C.
C. Okay. We'll see the answer. Correct. Correct answer is C. 814,000. Prakhar, kindly unmute yourself. There is a disturbance coming.
Sir, I am in the plant.
No, just unmute yourself. Unmute. Sorry, mute yourself. Mute yourself.
Okay.
Mute yourself. Okay, thank you. So the population after 10 years will be initial population into 1 plus growth rate to the power the number of decades. So it's a pretty simple direct question. So this is the answer, 814,000. Okay. So next question is, typically the peak factor of a community does not depend on. So on which of the factor the factor doesn't depend on? Is it dry weather flow,
Sir,
population
what
density?
is peak factor? Can you explain me, please?
Okay. So peak factor is a ratio of the maximum demand and the average demand. Okay. So in a day, suppose we are trying to find out like how much of water demand is there. So every hour we are calculating. Like in the first hour, there is a need of 2 meter cube of water. Next hour, 3 meter cube of water. So like that, we have found out what is the total demand of water. Okay, and then if we divide it by 24, we will get the average demand of water. Okay, is it fine? Now we also know there is a maximum demand in one of the time period.
Sir, it is like 1 year, 1 year. Matlab, I mean to say that 1 hour difference, na?
No, see, I am just given an example in terms of 1 hour. It can be peak factor can be hourly, daily, monthly, weekly, anytime.
Okay, sir. Okay, thank you.
Okay, so it's just a ratio of maximum demand divided by the average demand. So both the parameters should be same. If you are taking average daily demand, then you have to take the maximum daily demand. If you are taking average yearly demand, then you have to take the maximum yearly demand. So the ratio between the maximum and the average is the peak factor. So here we are talking about on which of the parameters the peak factor will not depend on. So anyone knows the, sorry?
A option.
A option. Okay, yeah, it is right. Dry weather flow, because other
Dry
things,
weather.
yeah, other things will definitely affect my peak factor. Okay, so the next and the last question here is average daily consumption of a town is 1,20,000 meter cube of water. The peak hourly demand will be, we have given the peak factor as 2.7. So here the peak factor would be a ratio of maximum hourly demand to average uh, demand. So in terms of hours, Hetu is saying it's C. Anyone else? This is the last question. Oh, we are telling D. Okay, fine. 13,500. Anyone else? This is the last question. Just solve it and we can finish it off. And we will see the solution. So D is the correct answer. We'll see how it comes. So the average daily consumption is 1,20,000 meter cube. It is given. So the average hourly flow would be 1,20,000 divided by 24. In a day, 24 hours. So we'll get 5,000 meter cube per hour. It is my average hourly flow. Now, so the peak hourly demand will be what 2.7 into the average hourly flow. That will lead up to 13,500 meter cube per hour. Is it fine? So these were all the questions that I had. So if you have any other queries, you can ask me or you can reach out to me in my mail address, that is saha19akash@gmail.com. And we will have the next session on 15th August, same time, 7 to 9 p.m. on Tuesday. And we will be discussing the questions regarding week 3 module in the next week. So if you have any more queries regarding week 2 module or week 1 module, you can reach out to me. These questions, see, these are all just questions which I wanted to help you in solving the assignments. You can go to my YouTube channel. The lectures will be uploaded there. Okay. So my YouTube channel name is Akash Saha NPTL. I will write it in the chat box. I will upload all these lectures in this YouTube channel. The week 1 lecture is already been uploaded, and you can access my NPTEL doubt solving sessions from YouTube. Is it fine? Anybody else wants to?
Okay, thank you, sir.
Okay. So if you are done, you can leave the session. If you have any more queries, I'll be here for 2-3 more minutes. You can ask, or else I will switch off the meeting. Payal, Nipu,
Yes, sir.
do you want to ask any doubts?
No, sir. Thank you.
Okay, then you can leave the
Okay,
session.
sir.
Thank you.